Okay, guys, we are going to talk about chemical reactions, so you should have some notes that look like this taped in your notebook, flap tape, and we're going to look at physical and chemical reactions. So go ahead and get your mind ready. Here we go.
Hi, please consider the following. I'd like to talk about two poisons that we can't live without. Talking about sodium and chlorine. If you breathe just a little bit of chlorine gas, it would do you in. You'd be out of here. You'd be a flatliner, just like that. You know what I'm saying? And watch what happens when we put just a small piece of sodium in water. Water like you might have on the roof of your mouth. This is pretty cool. These two chemicals, when they're separate, are dangerous. But when they're chemically bonded together, the pull of their electrons is so strong that they form a whole new substance, a whole new chemical called sodium chloride. Sodium chloride. Sodium chloride. Now, another name for sodium chloride? Salt. 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 Now, our blood is salt water. Our tears and sweat are salty, and so are potato chips. Thanks for joining me on Consider the Following.
All right, you guys are following along. Let's start with the first question in our Cornell notes. It's, what is a physical change? Well, a physical change alters the form of a substance, but does not change it to another substance. Basically, what that means is what the basic structure of it is still the same. We just change its appearance. So the example I have on the screen that you should probably write down is making orange juice. Okay. We all know that oranges tend to be pretty juicy. If you squeeze a little, you can get the juice out. Now, once I juice the orange, it's still orange juice at its core. It's still made of orange molecules, however they may look. Just the way it looks is different. It's going from more of a solid form to a liquid form. So basically, a physical change doesn't change what it is. It's still the same. So a couple different ways I can look at it is molding clay. Clay is still made of clay atoms. I can just change the shape. It's also like when you play with like your candy, like Airheads and Starburst, and try to make neat stuff with it. Or if I tore a piece of paper, I tear the paper up, but it's still paper. Now here's one that gets a lot of people. Water. Water can be in a solid, liquid, and a gas form. So in solid form, it's solid H2O molecules. In liquid form, it's liquid H2O. And in gas vapor, or your condensation form, it's gas form of water vapor molecules. Okay, now let's look at our second question. What is a chemical reaction? Well, when a substance undergoes a chemical change, it's changed from a different substance with different properties. So I use the example when we talked in class of baking a cake. And, most of us discussed that we like cake. So we talked about how when you put the ingredients together, that was your reactants. It's mixing your ingredients together. Then you put it in the oven, that's your yield, and your product is this fluffy, delectable treat if you baked it right. So a chemical reaction is basically something that you can't undo. You can't take this fluffy, delectable treat with this wonderful cartoon cherry here on top. You can't undo it and get your original flour and your original eggs and their original shapes and textures. It's something that will be incredibly hard to undo. So you have altered the atoms essentially. That's how we get our chemical equations. What I start with, I end with the same amount of what I started with. It just happens to look different. That's a chemical equation. So next thing that we have to list our 6 signs of a chemical reaction. So let's start with the first one, a color change. Now, some color changes are expected, but this color change we want unexpected. It is an unexpected color change. So I'll give you a prime example. Okay. When you have your leaves here falling on the ground. Okay. Now we all learn as early as kindergarten that the seasons are going to change and those leaves are going to change from that green color to these beautiful fall yellows and oranges. But that's not something that, even though you know it's going to happen, it's not something that you really think it's going to happen. It's an unexpected color change. Or let's say I took 2 clear liquids, I poured them together, and I end up with a black liquid. That's not so supposed to happen. Okay. Now, if I were going to mix up some Kool-Aid, I put some water in the jug, I put some sugar, you got to put plenty of sugar in there, and then I put a red packet of Kool-Aid flavoring. I'm expecting that color to change. Or if I put red dye into some water, I'm expecting the color to change. These are unexpected color changes that you're looking for these color changes. Number 2, we have the formation of a precipitate. The word is precipitate, precipitate, precipitate. And that's another fancy, science word. But another word for precipitate is solid. That means you're left with some type of solid at the end. So right here in this test tube, that's the precipitate. Okay. This area in this picture is surrounded by liquid, but I have a precipitate as well. It's when you're left with a solid over at the end. Number 3, bubbles, gas, or fizzing. Okay. So I look at both of these pictures. These bubbles are evidence that some type of chemical reaction has taken place. Temperature change. You've got 2 different pictures here. You've got a lit match. Once I light it, that temperature is going to increase. That fire has been ignited. Or a glow stick. Okay, and I'll show you a good breakdown of how a glow stick works if you've never used one here at the end. Number 5, odor or smell. Now, sometimes the odor can be pleasant, like when we're baking some fresh bread. Okay, I prefer to think of this as a cake. It just don't have all the icing and the good stuff and the chocolate on top. Okay, or it could have a nasty smell like rotting fruit or sour milk. Stuff that gets old does not smell well. Okay, and lastly, here's your release of light. This picture on the left here is some glow sticks and how it breaks down. So tells you that you have inside the glow stick, if you ever busted one, it kind of feels like you're cracking some thin pieces of glass. Okay, inside that thin glass, or what you think is glass, which is your hydrogen peroxide solution. Okay, and then you have everything in a plastic casing which you bend. That glass vial will break, okay, which is where your hydrogen peroxide solution is, and it releases that light for you. And that's where you get all these beautiful colors and stuff in your glow sticks. Or you can think of a firework as a light change or a light indicator for a chemical reaction. So now I want to show you some really neat video clips of just some chemical reactions that we have, and then I'll try to show you guys a few other examples of some things. Alright, so look at this picture. It is molded clay. I showed it early in the presentation. So is this physical or chemical? If you said physical, you're right. Alright, tearing paper. You also saw this picture, physical or chemical. If you said physical, you're right. I just tore the paper. I haven't changed what the paper is. All right, what about this one? This is frying an egg. Think about what an egg looks like before you fry it, if you've even ever fried eggs. If you said chemical, you're right. So think about some of the indicators you could have. If you notice you have a little bit of bubbling sometimes here on the side, or you have a color change because technically the white stuff looked a little clearer. Okay, so it's getting cooked. You have an increase in temperature change. All kinds of different indicators for this one. All kinds. All right, what about this one? Lit match. If you said chemical, you are correct. All right, cutting aluminum foil. Think about it. Physical or chemical, physical or chemical, physical or chemical. It is physical. It's just cutting. It's just changing the appearance of the aluminum foil, not changing what the aluminum foil is at its core. All right. Tums. Okay, giving yourself Tums for a rotten, sour stomach. Okay. Think about what happens to your Tums as they dissolve. It's being broken down by your body. So, is it going to come out the same? Can we undo this process? No. So, that's definitely going to be chemical. All right. Baking a cake. Okay. I use that example for your chemical equations. Chemical or physical. If you said chemical, you're right. Up. I'm sure people have had this happen before, especially when your mom has been teaching you how to do your laundry. That favorite little t-shirt you like to wear got bleach stain on it. Physical or chemical? Has mom taught you a way to undo that? No. If she has, you need to have her come talk to me, because this is a chemical change. It's a color change that can't be undone. All right, toast. Not one of my favorite things to eat, but people like it. Okay? So when I put my bread into the toaster and it comes out all brown and crispy, physical or chemical? It's going to be chemical. Okay. Juicing oranges for fresh squeezed orange juice that a lot of us are too lazy to make, but we like to drink it anyway. It's going to be physical. I've not altered what the juice is. I've altered its appearance. It's still the molecules of an orange. All right, what about this? You have tarnished silver tea ware, or however you want to say it. Not ware, but tea stuff. If people even drink tea like that. Okay, this one here on the left is tarnished. That means it's discolored. So color change or unexpected color change is an indicator of a chemical reaction. I'm not expecting my fine silver to turn this color. And ladies, if you've been buying jewelry or your man bought you jewelry that was once this color, but now is this color, it's fake and you should leave them. All right, what about sharpening your pencil? Physical or chemical? Physical or chemical? If you said physical, you're right. I'm just changing what the pencil looks like. I haven't altered its atoms or changed anything. Boiling water? Physical change. That boiled water is going to go from a liquid and it's going to condense into a gas, but it's still water vapor. Last one, rusted nails. Physical or chemical? Physical or chemical? Physical or chemical? Think about what you got to do to something that's rusty. Most of us just throw it away, or it ends up in some type of junkyard or something. You can't undo that. Okay? That metal has rusted out. It's been oxidized. It is no longer what it was. And it's gone through a color change. That's our indicator. So we've done a lot, looked at a lot, but I hope you saw enough examples to kind of help you, and we'll be practicing this throughout the next week.